Well, good morning, everybody. My name is Abdul Qadir Salam from the University of Lampung. Today, I want to use this opportunity to present the result of my current research in the University of Lampung. The title is The Use of One Normal Nitric Acid to Determine Copper and Zinc Level in Heavy Metal Polluted Tropical Soil. This research was stimulated by the fact that some heavy metal in soil are a micronutrient for plants, and almost all heavy metal in soil system are toxic at elevated concentration. However, there are limited choices for heavy metal analysis, and most of the available analytical methods were developed not for tropical soil. As you know that we have heavy metal in different form in the soil system. We can find some are dissolved heavy metal and some are structural heavy metal. Dissolved heavy metal may consist of complexes, chelates, and free cation. And structural heavy metal, we have exchangeable heavy metal, secondary mineral or precipitates, primary minerals, and also organics. So if we want to measure the concentration of heavy metal in the soil system, then we have to decide which part or which form of heavy metal to be measured. The objective of this research was to compare some chemical extractant for heavy metal analysis in tropical soil and to study the correlation between soil heavy metal extracted by nitric acid with their uptakes by several plants. Actually, there are three steps in developing the analytical method of heavy metal analysis. The first step is the comparison of several prospective chemical extractants. The second step is the correlation study with uptake by plants. And then the third step is the calibration study in the field. And in this research, I conducted only comparative study, the step one, and also the correlation study or step two. In step one, we use six different chemical extractants that include calcium chloride, ammonium acetate, DTPA, and also the stronger extractant uh, that was hydrochloric acid and nitric acid. And in correlation study or step two, we use soil sample with relatively wide range of heavy metal concentration, particularly for copper and zinc, planted with several plants. And at the end of the growing period of 4 weeks, we analyze the soil and also the plant copper and zinc. The soil sample we use actually were collected from an experimental plot set in 1998. And the soil sampling was conducted 22 years after the soil amendment with heavy metal containing waste, calcite, and cassava leaf compost. The existing heavy metal contaminated cell sample uh, is like this. We have W here for waste. We have L for lime, and we have C for the cassava leaf compost. And this experimental field was actually the uh, included in a long-term research I conducted from 1998 until currently. And the result uh, is can be explained like this, that from out of six extractant, we found that hydrochloric acid and nitric acid in this red area is was the stronger with high relative strength, and calcium chloride and ammonium acetate were the weakest with low relative strength. It is logical because ammonium acetate and calcium chloride extract only the exchangeable cation, not like hydrochloric acid and nitric acid. But between this extractant, there are close relationship. For example, here we have nitric acid and hydrochloric acid were well correlated with high correlation coefficient. But if we narrow the concentration range until only this red line, then the correlation coefficient was higher. You can see that here we have 0.36, and after we narrow the concentration range, then the correlation coefficient become 0.80. And this phenomenon was also observed for different pair chemical extractant, as you see from the improvement of the um, correlation coefficient from the red area here to the green area. But you can see that all of this extractant can be used to predict the availability of heavy metal in the soil system. The correlation of the extracted heavy metal from soil uh, were well correlated with the plant heavy metal analysis. You can see that for Caisim here, we have the correlation between soil copper and plant copper about 0.71. And for zinc, we have the correlation coefficient 0.96 is was much higher. And the higher correlation coefficient between soil and plant heavy metal also shown by copper and zinc for different plants. You can see that the exception is only for lettuce and for copper and for zinc in corn. And the conclusion of this research was the relative strength of the chemical extractant follows the order of nitric acid and hydrochloric acid in one group to buffer TPA and buffer TPA, the second group, and then the ammonium acetate and the calcium chloride in the third group. Higher correlation was observed for soil extracted copper by calcium chloride, ammonium acetate, hydrochloric acid versus buffer DTPA, and also for nitric acid, ammonium acetate versus hydrochloric acid. High correlation coefficient, high correlation for plant and soil copper extracted by nitric acid was shown by Caisim, water spinach, corn, and land spinach. And high correlation of plant also and soil zinc extracted by nitric acid were also shown by Caisim, water spinach, lettuce, and land spinach. That's all I have. Thanks for your attention.